Okay, so I've gotten a few questions about these rational function problems from Khan Academy, and I thought I'd make a quick video to talk a little bit about them. The instructions in Khan say to describe the behavior of the function q around its vertical asymptote at x equals 3. Now, in each of these questions, I do believe that Khan is expecting you to answer them while looking at a graph. So when it comes time for our test next week, should you see a question like this, let's make sure that we have access to a graphing calculator. Now here's one, Desmos.com, that's fine to use at home or for practice, but it's not going to be available during our test since I don't allow cell phone calculators. But the image is what I'm looking at here. If we can recreate this on a TI-84 or TI Inspire, that would be just fine. But in this image, you can see how the graph, this pair of red branches, we sometimes call them, they form this kind of this swooping shape, if you will. Ignore this line here. That's a glitch, I think, on the website. This vertical line in red should not be there. And sometimes it's there and sometimes it isn't. But if we're watching, from left to right on this graph, we can see how it increases from left to right as we move closer to x equals 3. And if we move from right to left, we can see how it decreases as we get closer and closer to 3. So at x equals 3, the vertical line assigned here, right, on the x-axis, we have a 3, and there's a vertical line that goes through it. That's what this red branch and this red branch seems to approach or get closer to. So I'm just going to look at this picture instead because the website was moving around a little bit. And so what the question is really asking here is, what's the behavior of the function g of x? Well, let's remind ourselves that this function notation is simply a representation for the values of y. So what do the y values do as our x values get closer and closer to the number 3? Now, some new notation that you might not be familiar with is this idea of x arrow 3 minus. Well, this is our way of saying as x approaches the number 3, so as we approach 3 on the x number line, this little minus sign means from the left. And this little plus sign here means from the right. And so the behavior of the function q or q of x, is a representation of the y coordinates. So what are the y coordinates doing as our x coordinates approach 3 from the left and as they approach 3 from the right? Well, as our x values approach the number 3 from the left, these are all the x coordinates. These would represent all of our y coordinates, and where they intersect, of course, is the point on the graph. So what's happening to the y values on these points as x gets closer to 3 from the left? Well, these little blue dots that I'm drawing here, they're racing off towards positive infinity. So from the left, as x approaches 3 from the left, our y values, or g of x, is going to approach infinity. In this case, as x approaches 3 from the right, g of x, our y values, well, you can see here, if we start plotting these points, our y values are going to approach a negative infinity because they're racing downward towards that asymptote. So on Khan, I don't really like option A because that's saying that the y values are racing towards positive infinity in both cases. I don't like option B because, well, that's telling us that from the left side we're racing towards negative infinity. That would go downward like that. And from the right side, that would go upward. And that's not the shape that we saw. For option C, well, this one looks promising, doesn't it? As we approach 3 from the left, we're racing up towards infinity. As we're approaching 3 from the right, we're racing down towards negative infinity. I think that's the one I would go with. And for good measure, part D, yeah, that doesn't look any good because as we approach 3 from the left, we're racing down towards infinity. As we approach 3 from the right, we're racing down towards infinity as well. So this is the shape that we saw on the graph, so option C is the choice that I would make. Now in a calculus class, we often approach this problem and consider its factored form. And with its factored form, we see that these factors can cancel. That's what we call a removable discontinuity. That's going to create a hole in the graph. But ultimately, when the factoring is finished, we have x minus 5 over x plus 3. Oops, I think I just made a mistake here with my factoring, and I just caught it. We should have x minus 3 and another x minus 3. Sorry about that. Hopefully you caught that mistake too. So in this factored form here, the 0 in this denominator is what we call a non-removable discontinuity. This guy here, since x is not allowed to be equal to 3, that's going to cause a violation for our quotient. And this is what implies that there's going to be a vertical asymptote. And we talk about this in terms of the phrase limits. We introduce this phrase called limits, and we can investigate asymptotic behavior from this point moving on in a calculus class. But for right now in college algebra, it's good for us to understand this notation, and I have a feeling that that's what most of us were having some struggles with, this approach notation and the fact that the minus sign and the plus sign after a number simply means left or right. I hope that helps. Thanks for watching.